Hello everyone, welcome to Dakshana e-classroom program. So today we are going to start a new chapter and that is alternating current. Okay, current, everyone is aware, like flow of charge, rate of flow of charge, we define current. And you can see like how important it is in our life. Right now, you can't just imagine your life without power, without current. We look at it actually, so there are two type of current, or there are two type of sources of power. That one is alternating, another is called direct. So most of the things that you have studied up to now in your syllabus in the 12th class, this is or like that is all about most of the things. Remember that DC. So here DC means direct current. Direct current here, like this is the simplest example of DC. So if I write I current varying with time is this is simplest example of DC where direct current. Here current flow only in one direction and its magnitude is also even constant. So in this situation, like how power supplied, heat generated, everything, if anything is asked to us, we have done it, we know everything about it. And you must be knowing sources of this type of like basically, for example, so that is like batteries are simplest or easiest source of direct current or direct voltage, is it? They maintain some constant potential drop. Some direct generator are also there, they are DC generator which generate DC current and DC voltage. This is, and here if I say like this is also direct, but actually it's a little bit different. You can write it either it's a variable DC current because it's not changing its direction, it's moving, it's flowing only in one direction. So this is also a direct current but not constant magnitude. This is direct current, again I, or current and voltage versus T, direct current or at voltage, is it, but variable magnitude. Actually this, if we look at it, that how we can get it exactly, this we can get by superimposing DC over AC, then actually you will get this source. The point is this is also direct source. The thing is that, so there can be many different possible direct sources and we have seen, and if anything is asked to you, power supplied, heat generated, current through any system, inductor, capacitor, how like resistor, everything we have when such sources are applied, we have seen that, is it? Next comes is alternating current. Alternating current, if I just look at it, the definition, it is the current or voltage, I will define it, alternating quantity. It is the one whose magnitude changes from 0 to maximum with time and direction changes periodically. That means, look at it just here. So this is our powerhouse and let's say this is your home or maybe some factory where we are supplying the current, is it? So in case of direct, it simply flow from one point to another, always direction is maintained that way. This is DC. In case of AC, this is same home and this is the power generator. So in case of AC, actually it flow this way, this way, this way, this way, this way, this way. It keep on like right, left. So if you look at it here, its magnitude is changing continuously, and for this to this interval, you can say this is my T half interval, it's in positive direction. It's like, I will say it's flowing towards right. Then from here to there, it's flowing towards left. It's flowing towards right. Again flowing towards right, then left, right, and then left. So this way, the alternating quantity changes its direction, changes its polarity if it is even battery also. The thing that we are going to study in this chapter is little bit more about it, how we can understand an AC. In this situation, we know the things. elements normally that like register anything like fan, tube light, and like those things like heater, they are equivalent to some or treated as some like resistors. They are consuming power, so basically they are resistor. And some have like capacitor. We have different elements, so some are made of capacitor or inductor. So now if some alternating power, alternating current and voltage is applied across these elements, how they will behave, because these are important to understand us for us. And another point is these are important for our exam purpose. In exam you will be asked such things. So then how we can study? So there is proper systematic things has been like derived and discussed. We will just try to understand those things. We are not going to do any research. We will try to understand the things that has been already developed by the scientist. Okay, so this is that we are here right now talking about alternating current. Actually there was this DC it was in around 17th century. Alessandro Volta first time discovered one source of battery, so that we can say discoverer of DC. But after that Thomas Edison worked a lot on it and to apply it, to use it in the real life actually. And at that time Tesla, Nikola Tesla, that he was from Austria, some like part and country you can say in Europe. So Nikola Tesla was from Austria, and he moved to Thomas Edison, or to with his Thomas Edison to work actually, because he was very much interested in power. And at that time only Thomas Edison was working on it to power to light the world, right? So there was like interesting story between Thomas Edison and Nikola Tesla, that is also termed as AC-DC war, because Thomas Edison used to favor a lot DC. He wanted to power the world with his DC current. But Nikola Tesla was like, he was very intelligent also, and he was having better idea to power the world, and that was basically the idea was alternating current. So the alternating current is because of Nikola Tesla that we are seeing. There are many advantages, disadvantages of alternating current. Initially the story began between them, that Nikola Tesla reached to Thomas Edison laboratory. Edison assigned some work to Nikola Tesla, and there was some like complex situation where like Thomas Edison was working, but he was not able to get the solution of that problem. So Edison actually assigned that to Nikola Tesla, and he told, you are showing like you are intelligent, okay, then you work on this problem. If you are getting the solution for this, then I will award you $50,000. And at that time $50,000 was huge amount. It was not small, even now also, but that time it was like huge amount. So Nikola Tesla worked on that actually, and finally he even got solution and even suggested some better method to solve that problem. And when he presented that to Thomas Edison, and he asked like, okay, now you give me $50,000. Then Thomas Edison told, actually you are what, you do not even understand the humors of Americans. I said that just in like, it was just a joke, it was not serious. Okay, then after that actually Nikola Tesla feels cheated. He thought like he worked so hard, he solved the problem, and he was like supposed to be awarded $50,000, but he was denied by Thomas Edison, whatever the reason may be. But he told that exactly that it's humor of Americans, you must understand that it was not true actually. So then after that incident, Nikola Tesla left Thomas Edison. He even worked in field, he worked hard actually, and he was having like his idea of alternating current, generating alternating power. And at that time there begins the bar, because Thomas Edison was working, he was deploying, he was starting powerhouses at different locations. He was planning to light the New York. He was starting his company, and he was planning to. And at that time, because Nikola Tesla was not having any money, so he used to present his idea to rich peoples in America at that time. And Westinghouse was one scientist actually. He was also like rich at that time. He liked the idea of Nikola Tesla. Westinghouse started his company and he was ready to invest in Nikola Tesla's idea. And after that, actually, so there were like contract to light New York City, and one company was Westinghouse and Nikola Tesla, that was based on alternating current. Another was Thomas Edison, who was like interested in powering the like New York City or the whole America later on with DC current. But the point was, the twist here comes is that Nikola Tesla's and Westinghouse company got that contract, and this was a huge loss to Thomas Edison. He was defeated actually at that time, and he was defeated so badly that he could not even like cope up with it, and it started like negative days or bad days for Thomas Edison. Later on, actually, Westinghouse lighted the New York and everything like. In AC, it has like many benefit also. Benefits are all, is that you can send it to huge distance, like like from the powerhouse to the, is it home or bad like factories, that it can be generated at large distance and can be like supplied at large distance, maybe in thousands of kilometers. But in DC, that is not possible. You can only supply it up to few kilometers only, maybe maximum 100 kilometers, not more than that. So that was the problem. So right now you can imagine if like we sit in the cities, big cities, and the power comes actually from far away areas. That is possible only because of Nikola Tesla's alternating current. Okay, so this was just a little bit about the story, or we call that AC DC war. So you can say that finally Nikola Tesla won the war, but actually in practical things we see, it was not also a big win for Nikola Tesla, because he did not got much like appreciation, much money for that, and his life was also not that much good. He did not enjoy much of his like work. So that way, yes, you can say the like the contract and the like war between current, that Nikola Tesla won, but still he did not enjoy that victory, basically, I will say. So this was a little bit, so that is how basically things. So if we just look at it, the source, then for DC source there are DC generator, and the simplest things like all the batteries, your mobile phone battery, your is it small watch batteries, these are all like direct current source or direct voltage source. And AC, you must have studied like in EMI we talked a little bit about, actually we are like constantly changing magnetic flux is linked, and that was generating some sinusoidal voltage and current. These are AC. Still I will talk about a little bit. Let me tell you about how AC is generated, and before that I am just talking a little bit. So AC, the definition is that AC alternating quantity. AC means alternating current. We define right alternating current chapter name, but actually it's like it can be alternating current and alternating voltage also. So quantity, alternating quantity, we define this a quantity whose magnitude changes continuously with time and direction reverses. First let's say right, then left, right, left, right, left. That is basically AC. AC, this is one of the example, and this is called sinusoidal AC because this can be expressed in either sine or cosine function. So this is like most frequently used, easiest to generate, and we will in this chapter talk about mostly this type of AC. But AC current can be also, or AC quantity can be in different form also. This is also your AC if it is continuously changing, but this is rectangular AC, plus minus plus minus plus minus. This is your rectangular AC, alternating current or alternating quantity. Is it? If I write current, then it's AC, otherwise I and V, then it will be alternating quantity. Is it? So that is also another example of alternating. Similarly, there are different possibilities. It's not like only this is the AC. No, there can be other. So another is triangular. This This is also AC, plus minus plus minus plus minus plus minus. This is triangular AC, is it? Similarly, there sawtooth, plus minus plus minus plus minus plus minus plus minus plus and so on, minus. So this is sawtooth AC or alternating quantity I and V. So these are all different form or different types of alternating power sources, alternating current or alternating voltage. We will mainly in this chapter focus on this type, but still before that I will talk a little bit about, because the thing is that for DC we know everything. Current, power, voltage are like heat generated, resist, anything if it is asked about DC through any element, inductor, capacitor, resistor, we are in position to answer that. But remember that you are right now not in position to know that how an element means resistor, inductor, capacitor will behave when this type of source is applied across it. So we will try to understand that. And before that, this is, if it is changing its direction, then how exactly it's working still things, how still we are getting heat and all that. So we will try to correlate for these AC with the DC little bit, and for that we define few quantities, that is your average value, mean value and all that. So before going for that, let me first tell you how it is generated, and that is AC generator. Okay, so let me tell you how actually AC generator work and how AC alternating current and voltage source are produced or voltage is produced. So the setup for or basic principle for AC generator looks like this. Here we have some two permanent magnets, south pole, north pole. They are creating some magnetic field in this space, and there is one rotor actually. This is generally made of iron something, and on that some conducting copper wire is wrapped in loops. So let's say it has n number of turns, okay, and one the copper wire here connected this slip ring 1, another slip ring 2, actually one end, you can say another end. So these are slip ring, and now what is happening in the generator, we provide mechanical energy, is it? So we rotate this generator by some mechanical energy, and that can be basically your hydro, in case of hydro, it can be the mechanical energy can be from turbines, is it? Hydropower plants, there we use turbines. Water from height falls and that runs the blades of the turbine, and that actually used to run this generator. So similarly it can be powered by some coal, burning coal, that will produce steam, and that steam is used to run the turbine and so on. So different ways we are ultimately converting some mechanical energy to electrical energy in this situation. So how exactly things work here is that this is your rotor and this is a coil. This I'm talking about for one phase. Actually the normal thing that we use in our homes, it's a three-phase AC. I will tell you what is that also, three-phase. So here slip rings are, so that it's rotating, and here power is taken out from this. The basic thing is here is that, let's say these two permanent magnets are producing some magnetic field in this, and once this rotator will be rotating, after some time its orientation will be like this. So in this situation you can say the magnetic flux through this wire is through this coil or through this loop is minimum, there is no flux, is it? But because it's continuously rotating, right, so it's this is the orientation at this moment of time, magnetic field lines are this. So then in this situation you can say the magnetic flux through this wire, this loop will be maximum, and once it started rotating like this flux through this coil or flux through this, I will say, loop will change, is it? And I can express that flux actually. So let's say this is the orientation, initial orientation of loop, right? It has n turns, basically this coil has n turns, one turn I'm calling it loop actually. So in this situation here I'm just to simplify you, I am considering one turn only, so that I'm taking copper loop. Okay, so now initially the area, this is the magnetic field direction, left to right, and area vector for this I'm taking this direction. So the initial phase flux I can write phi initial, it will be equal to B multiplied by A. Clear? But as it turn through, because it's rotating with some angular speed, so at time t I can add the theta through which it has rotated. Theta is related to this, theta is equal to omega into t. Omega is angular speed of this rotor. Okay, so omega you can write here angular speed of rotor. So with which this rotor is rotating. So after that this coil will be in this orientation. So let's say this is also, then you can say B is still in same direction, and where the area vector of this loop has turned by angle theta. At this moment of time the flux can be, is it? So at time t, flux through loop, phi, what I can write, I'm just considering one, this is B A into cos of theta, because this area vector can be resolved into two components. So this is B, this is A cos theta, that will be this, and A sin theta, it will be oriented this way. So sin theta orientation will be this way. So the flux through sin theta component will be 0, and flux through cos theta component is given by this, right? So now I actually got flux through a single loop, is it, at time t as your rotor rotate. So phi can be written as B A cos of theta is omega into t, is it? So if there are n turns in coil, this is a copper coil which is having n turns or n loops, then phi net can be written as NBA cos of omega t. So this is the flux, right? Now what is happening, this flux as this rotor is continuously changing. So just try to imagine it. Right now in this situation, this is the orientation of this loop. The magnetic field lines, maximum magnetic field lines are crossing it, so I will say the flux is maximum. And after some time it will rotating, and let's say just after some time, that will be t by 4 moment of interval of time, the orientation of this loop will be this way, and no magnetic field line is crossing this. So from this to this, the flux changes from maximum to 0, and after some time what will happen, it will again come this way, then flux again changes to maximum. It will be like minus, in one case it's plus, in another case it will be minus, then again it's changing like 0. So here you can see the flux is continuously changing. Flux as function of time we can express this way. And from Faraday's law, what we know, the EMF induced in this coil, is it? So EMF induced I can write actually, so the EMF induced, so this EMF is equal to what? Minus of d phi by dt. This is phi, I can differentiate that, so then it will be minus d by dt of NBA cos of omega t, and EMF I am finally getting its NBA omega sine of omega t. This quantity we write it the magnitude, is it, or we also called it the peak value. EMF is equal to some E naught into sine of omega t, and you can say this is what exactly we are getting. This is alternating EMF, alternating voltage. If you plot it, it will be like this, initially starting from 0, positive, negative, like this. So this is the exactly EMF, like here you can write E versus time, and if it is passes through some resistor, then that will generate alternating current. So basic thing, like it's very easy, and most of the like generators, thermal like plants that are working generating power, they are generating AC source, then it is converted into DC. How it is converted? We can convert that by using rectifier that we discuss in semiconductor part actually. So this is the basic principle of an AC generator. I hope you are clear with this basic thing. Two permanent magnets means that can be like done in different way. Point is, there must be some permanent magnet and there must be some magnetic field. Through that magnetic field, this rotor, like basically this coil is rotated. Coil is rotated means flux through the coil is changing with time, and that changing flux will produce actually induce EMF, or that changing flux will induce some EMF, and this EMF we can see is also changing with time, and that is our alternating EMF, alternating current. So that is the working principle of AC generator. And here it's like for half cycle, positive, negative, positive, negative. So current, like you can say in a half cycle it will be like flowing current flowing this way, it's going this and coming this way, like you can say going out and in this way. In another half cycle it will be reversing its direction this way. So in one way current is going this way and going this way, and another way it will be going this way. So that is how actually it's positive, negative, positive, negative, and we call this is the working principle. That is how your AC generators generate alternating source of EMF or alternating EMF. Let's next see more about like this term. So here this EMF, like we write, this is what instantaneous EMF. This is the maximum value, we call that peak value. Omega t, we write its phase. Okay, so then we try to correlate this quantity alternating with some DC, and we write here some quantities, that is average and mean values, and let me tell you those things. Okay, so finally from AC generator we got alternating source, and that we are getting, if it is voltage or EMF, then I will write it E naught sine of omega t. It can be also current source, but I is equal to I naught sine of omega t, may be expressed in terms of cos also, there is nothing wrong, both are exactly same thing. And here we understood that this like both we call its alternating quantities. They will be positive for half cycle, negative for half cycle, and here omega we write this is angular speed, and this is also equal to 2 pi f, where f is the frequency of rotor, is it, at which it is rotating. And the relations you know actually already, omega is also 2 pi by t is the time period, so it will be like half. So this is for half t by 2, this will be positive cycle, this is negative half cycle, this is t by 2, negative, positive, negative. So for half of the duration of one cycle, the current, the EMF will be positive, for next half it will be negative, and that is how it is keeping on changing. So finally we have a source of like EMF, alternating source, and I am expressing it this way, omega into t. Now here this E naught, it's called peak value, or also called amplitude of AC or alternating voltage. This E naught is called peak value or amplitude of alternating. Similarly, if it is I current, then it will be alternating peak value of alternating current. Okay, and here we define few more things. That so first thing is, you can see here, from if starting from this to that, some current is flowing positive, from here to that exactly same amount of current will be flowing negative. So over the complete one cycle, the average current will be 0. So but it doesn't imply that it's not creating any effect, it is creating some effect. So we calculate here some values, let me define that. That is average or mean value, right? So this is x naught sine of omega t. X can be my EMF or it can be my alternating current also. X naught is your peak value. Then what is the average value of this? Is it if this is a alternating source representing either EMF or current, then for this what does we mean average or mean value, right? So first thing is for a complete cycle we can write x, we denote it mean or average, x bar is equal to 0, because you can see for one half cycle it will be positive, next half cycle it will be negative. If I add it complete, then it will be 0 divided by, and we are getting 0. So and the formula for any quantity, this is let's say integral, then we can write in one way is x1 plus x2 plus x3 xn divided by total number, that is also average. When it is constantly varying, then we write this is, let's say, x is equal to r function of t, so this I will write x t dt divided by dt, whatever the duration you want to calculate. So this is the expression for average value. So in case of these AC or alternating quantities, we calculate the mean value or average value for half of the cycle. Is it so? Mean or average value for half cycle, because it must be clear to you that for full cycle it will be always 0, as for complete cycle it will be 0, right? Next, so now what I can write for complete, so now I'm calculating it for half cycle. So x equal to x naught sine of omega t. I'm doing the calculation for general purpose, then I will write the result for both current and EMF. So then x for half cycle, this will be equal to integral x naught sine of omega t dt divided by integral dt 0 to t half, 0 to t half. Clear? And this implies integral, this will be simply t half, x naught taken out, integration of sine omega t dt will be like minus cos omega t. So I am writing x naught by t into 2, and this is minus, and integration of sine is cos of omega t divided by omega, 0 to t half. Clear? This implies minus 2x naught by t into omega into, if I substitute the limit, so when I am substituting cos of omega, I can write 2 pi by t multiplied by t half, that is t half minus cos of 0, right? So what is this? Cos 0 is 1, and cos this tt gets cancelled, this is pi, so this is minus 1, minus 1, minus 1, minus 2, and minus here. So then I am getting, this is basically minus 4x naught upon t, I can write 2 pi by omega multiplied by omega. This gets cancelled, and finally I am getting basically, or one more thing, minus is also gone, so and 2 gets cancelled, then it's x naught divided by 2x naught divided by pi. So this is the average value of this quantity over half cycle, that is 2x naught divided by pi. So in general term I can write mean or average value value of you will write E equal to E naught sine of omega t for half cycle. So this you can write E average is equal to 2 E naught by pi. Similarly, I is equal to I naught sine of omega t, then its average value again for half cycle, it will be 2 I naught divided by pi. So these are two relations we got. This is called average value. So I hope you understand. That is, next is root mean square value. Let me just erase this part. Okay, so the next is root mean square value, or we call it RMS value. So here let's say if X is any alternating quantity that can be alternating current or alternating voltage, I'm writing the expression in general terms, then I will write it for current and voltage separately. So what is the meaning of root mean square value? So first let me tell you how we calculate RMS value. So let's say X is given as X naught sine of omega t, where you know X naught is the peak value or amplitude. Then RMS value of this is given by X RMS. This is equal to root. R means root, M means mean of square. So mean you write means average, mean of square. So mean of square we have already just like back we saw mean of some function fx dt integration dt. This is what mean, average value of this function over the interval of time which we are interested to know, right? This is the mean. And what is it here? It is mean of square, root mean square. So this means mean of square and root of that. So here I will calculate mathematically, it is equal to mean of square, so means of square x square t into dt. This is the divided by integral dt, and here we calculate it for complete cycle. So what is this? This is the mean of square, you can see square, and the root of this complete quantity is termed as RMS value, or we call it root mean square value, right? So let me just do the calculation for this part. There here I can write X RMS, and that is equal to, if I substitute the values, integral, here it will be X naught square sine square omega t dt 0 to capital T integral dt 0 to capital T. Correct? Let me simplify it now. So here this integration will be simply t, x naught, its amplitude can be taken out, then it comes x RMS is equal to, this is x naught, even it can be taken out from the root, and inside it is integral sine square omega t dt divided by, if I simply integrate it, then it will be t and it's 0 to capital T, right? So the sine square integration I can write x naught integral, this is integration of, we know cos 2 theta is equal to 1 minus 2 sine square theta. So by using this trigonometric identity I can actually substitute here sine square theta. Here I can write sine square theta is equal to 1 minus cos 2 theta divided by 2. So this is 1 minus cos theta here omega d 2 omega t into dt whole divided by 2, this term, and 0 to t, and root will be also here t, right? I hope this is step clear. This is just step 2. I can write the integration directly also, but to explain you, so to integrate this we are expanding it and writing it by using this relation in this form. Then it's coming out to be x naught and complete. So integration of this 1 by 2 also I can take it out, 1 by 2t, and here it's integration dt, so that I can write t integration of cos, it's like sine of 2 omega t divided by 2 omega and limit 0 to capital T. Clear? Okay, next is x naught divided by here 1 by 2 capital T. If I substitute here limit 0, then it will be 0, and T, then it will be T minus here. Similarly, I will be writing here 1 by 2 omega and sine of 2 omega capital T. So if I substitute T, then omega is 2 pi by T. So T gets cancelled. It will be like 4 pi, and sine of n pi 4 pi will be 0. I can write it 0 minus here sine of 0, and that is also 0. So this complete term is simply becoming 0, and here I am left with T. This is cancelled out, and we are getting with x naught divided by root 2. So this is the RMS value of this sinusoidal or alternating quantity x, where x naught is the peak value. So this I got general expression for the RMS value. Let me write the RMS value for alternating current and voltage. This is the method, the meaning how we calculate. X is given as x naught sine of omega t, then x naught is peak value. RMS means R means root of mean of square. So square come mean, and square mean and root over that we call it x RMS. So that is, and after calculating we are getting peak value divided by root 2, right? So here I can write for alternating current, is it? Then I will write I is equal to I naught sine of omega t. Then its RMS value is given by I naught, its peak value divided by root 2, exactly by calculating same manner. Okay. Similarly, for alternating voltage, I can write if V is given as, or E is given as E naught sine of omega t. Sometime it can be given as V is equal to V naught sine of omega t, because voltage or EMF we either write in terms of small e, or we can write also in terms of V. So here E RMS is equal to peak value divided by root 2, or you can write V RMS is equal to V RMS is equal to peak value divided by root 2. So these are like RMS values. Here, like you know that in our house or supplies, wherever we are getting the voltage, and it's mentioned as 220 voltage. What is that actually? So in general term here, I mean is that whatever the supplies we are getting, is it, and wherever you read some voltage rating or all that, those all values are given in terms of RMS value, not the peak value, is it? So all the mentioned values of current or and voltage are actually RMS value. The supply, is it, we get in our homes, and it's rated as 220 voltage. This is also RMS value of the voltage that we receive in our home. The peak voltage, peak value, we write it V naught, that will be equal to root 2 times 220, and this is equal to 311 voltage. So the peak value of the supply that we get in our homes is actually 311 volt, is it? So this is about RMS value. What actually we mean RMS value, is it? This is the mathematically that how we calculate. We understood that RMS, root mean square, root of mean of square of some like alternating quantity, and we calculating and getting this expression. Normally whatever the like, because the supply that we are getting in our homes is AC, so many times like in many appliances, maybe on electric fan, tube light, is it, whatever you see, some readings are given that operate at 220 volt, 5 ampere, 2 ampere, and like that, etc. current. So those all ratings given in terms of voltage for AC, is it, those all are actually RMS values. So the peak value, we understood this. Now the point is, physically what we are not getting its feeling, what is the meaning of it actually, RMS value. So RMS value actually it give you the effective value, is it. So let's say if we have one direct current, okay, let me try to explain you. So before that, let me just erase it. So what is the exact meaning, how you can feel it, what is the meaning of RMS value? I am trying to make you understand that. So here, if let's say I naught or I is the direct current, is it, passes through a resistor R for time dt, how much heat it will produce? I can write I square R into dt. If alternating current I is equal to I naught sine of omega t, if same current is passed through same resistance R for same interval of time, then to produce exactly same amount of heat, what should be the value of this current, effective value of that current, so that if it is passed exactly, we will pass alternating current, is it. So then if alternating current of this is also passed through resistance capital R for same time interval or duration, then to produce same amount of heat, so that same amount of heat. So in that case, I is what? DC current. Peak value is I naught. This is AC current. Then its effective value such that it's working exactly just like DC. That effective value we call it RMS value, because mathematically it comes out to be that expression I just derived. So now this is a DC current passed through resistor R for interval of dt, heat produced is this. Here I am passing now a AC current, alternating current I is equal to I naught sine of omega t through same resistance R and for same interval of time, and I want the heat produced in the resistance R should be equal. So that means heat is equal to, here you will write I square R into dt, I will write I naught square sine square omega t into R into dt, and this heat must be equal to this. So this implies I square R dt, I will write I, its DC value, and this is equal to I naught square sine square omega t R into dt. These two quantities should be same. Then I am getting it actually, here R gets cancelled, or I dc square, I can write I naught square sine square omega t dt divided by dt. So if the interval is quite large, then I can write this is also integration, is it, and to get I dc, this is also called I effective, and that in terms we call RMS, and this is coming out to be root over this. So under root already integral, this is I naught square sine square omega t dt 0 to, if I am taking the interval for one cycle, then it's interval 0 to t. So you can see here we are getting exactly same value, same expression. So if I is equal to I naught sine omega t is an alternating current, then its RMS value you can call its effective value or a value of current that is equivalent to a DC current, so that both when passed through same resistance for same interval of time should produce same current. So like I naught is the peak value, then what should be its like effective value? Then effective value will be given by, we get here I effective is equal to I naught by root 2. Mathematically that is how we calculate it. So that is the meaning of RMS value. Many times it is asked to you, you must know the relation, what is RMS value, what it mean actually, and this is all about RMS value. We call it root mean square value of alternating current or voltage. For both it's equal to peak voltage divided by, or peak value divided by root 2. Okay. Okay, so two more terms here. You just need to know sometime if it is given somewhere, then you must understand its meaning. So one term is form factor. It is defined as the ratio of RMS value of alternating quantity to its average value over half cycles. Simply that ratio we call form factor. So if X is any alternating quantity, then value of X RMS divided by X average over half cycle, because you know X average over complete cycle will be 0, right, for sinusoidal function. So if I talk about the form factor for alternating current, is it, then what will be that? So I know the form factor for alternating current, that will be equal to I RMS divided by I average over half cycle, and I RMS is I naught divided by root 2. And what is I average? We calculated it's 2 I naught divided by pi. So the form factor, it's coming out to be, after solving it, you will get I naught gets cancelled. This is pi divided by 2 root 2. This is the form factor for alternating current. Clear? So similarly, there is one more quantity, one more term, that is called peak factor. So it is defined as, it is the ratio of peak value to RMS value of alternating quantity, that is termed as peak factor. So peak factor will be, it's simple term, just need to remember. If anywhere it is given, maybe like sometime you are given form factor and magnitude of, let's say, some RMS, then maybe average value, something like that, some relation may be asked to you. So if you just know the term, then you can answer it easily. So peak factor, it's, you can write peak value divided by RMS value. X peak, X RMS. So this is what, if I talk about peak factor for alternating current or voltage, then that will be equal to what? Peak factor. So peak value is, let's say if I talk about alternating current, then it's I naught, and RMS value is I naught by root 2. So this will be simply equal to root 2. So these are just few terms for like that is called form factor and peak factor. Okay, next term is peak to peak value. Peak to peak value. So it is sum of magnitude of positive and negative peak values. That is termed as peak to peak value. So if I talk about peak to peak value of alternating voltage, is it, and that is sinusoidal. So if this is an alternating voltage and this is V naught and this is minus V naught. Then what will be its peak to peak value? So that you can understand simply peak to peak value. So this difference, and that will, so V peak to peak, you can write it, that will be equal to V naught. Remember, it's not it should not be added with minus sign, it should be just magnitude. So V naught plus V naught, that is peak to peak value. So this is 2 V naught, and this can be also written as 2 because V naught can be written in terms of RMS value. It's root 2 V naught, so that is your, now it would be RMS. Simply this is your termed as peak to peak value. Similarly, we can calculate peak to peak value for current also. These are few different terms, terminology related to alternating quantities, alternating current and voltage, because now we are moving to alternating quantities, and that is different from direct current. In case of direct current, we do not need all such quantities, we do not even calculate, but here we need to define different terms because at different places these things are required and they have proper meaning. So that's why we are supposed to understand them properly. Try to remember that. Let's see next how, when alternating quantity or alternating current and voltage is passing through an circuit element, that may be your resistor, inductor or capacitor, then how all these things behave and how we study. So for studying, because it's little bit different from direct things, so that's why we need to create proper systems so that we can understand things in proper manner. So for understanding the behavior, that how resistor, capacitor, inductor will behave when they like alternating current, alternating voltage is passing through them. So for that we need to understand one more term, and that is called phase and phasor. So let me discuss that in the next class. Thank you so much.